Hey kids, Flexing Teacher Weber here. Hope you're having a good day. We have been solving math equations. Previously, we've been solving math equations using addition and subtraction. And today we started looking at a different kind of math equation. So I had the kids start off with a problem and I had them solve it any way that they wanted. So this said every Slurpee Jack buys is $2. If he spent $12 on Slurpees, how many Slurpees did he buy? Well, many kids went and did this, which was great. They said, okay, so he has $12 to spend on Slurpees. Every Slurpee is $2, so they took $2 and they saw how many $2 would fit inside of $12. And that would tell you how many Slurpees you have, and you have 6 Slurpees. So many kids did that, which was great. And many kids did this as well. They made a chart that compared Slurpees and cost. And they said, okay, well, 1 Slurpee, $2. 2 Slurpees, $4. 3 Slurpees, $6. 4 Slurpees, $8. 5 Slurpees, $10. 6 Slurpees, $12. And once they got up to $12, they knew that was 6 Slurpees. And that was great. And then what I talked to them about is that this relates very much to what we did in our previous algebra unit. So typically we would have called Slurpees X and cost Y. And I would have said to them, what do you have to do to Slurpees every time to get the cost? And it was always multiply by 2 in this case, right? Every time you multiply the Slurpees by 2, you always get the cost. So if we wanted to represent that as an algebra equation, we would say Slurpees times 2, which is 2x. And then that equals the cost, which is y. And that's the kind of math equation we looked at in our previous section. And we also would write this as, we could also write it as y equals 2x. But this time what's different now is now we have a value for y. 2 times the number of Slurpees equals $12 in this case. We've been given a value for y. And this time we want to know the value for x. Now, when we were solving equations by addition, we solved them by subtracting. When we were solving equations by subtraction, we solved them with adding. We always do the opposite. So this one here, we have multiply by 2. To solve it, we want to divide that side by 2. And if we do it to that side of the equal sign, we have to do it to this side. Now, 2 divided by 2 gives 1x. And 12 divided by 2 gives 6. Or another way of saying that, 1x, in algebra, when you have a variable like x with a 1 in front of it, that's the same as saying just x equals 6. So x would be 6 Slurpees. So what we're going to be doing today is we're going to be taking this idea of solving an equation that has a multiplication in it by using division. So that's our goal for today. So solving equations by addition when the equations look in this form, ax equals b. So this says solve each equation by showing what you would do to both sides of the equal sign. So this one here, number 1, this means 3 times some number equals 15. So since this is multiply by 3, to solve it, we're going to divide by 3. And we're going to show that division by making a fraction. We're not going to do that. We're going to show it by making a fraction. And if we do that to one side of the equal sign, we have to do it to the other side. Now 3 divided by 3 gives 1x, and 15 divided by 3 gives 5. And 1x is the same as just saying x equals 5, which is exactly what we want to show. Now, just like before, we're going to check our equation as well. So our equation was 3x, 3 multiplied by some number equals 15. So I will work down the page and I'll replace my x with 5, which was the answer. And is that statement true? Does 3 times 5 equal 15? Absolutely. And since both sides of the equation are the same, you can check that off. Okay, number 2, same idea, different variable. 11t equals 44. 11 multiplied by some unknown number equals 44. To get the t by itself, we want to do the opposite of multiply by 11, which is divide by 11. And I have to do that to both sides of the equal sign. Now, as I solve the equation, 11 divided by 11 leaves me with 1, and I still have a t. And 44 divided by 11 is 4. 1t is the same as saying t equals 4. Now, to check that equation, beside the equation, we write check. And we write the equation 11t equals 44. Replace the t with 4. This means 11 multiplied by t. We use parentheses to show the multiplication because we don't want to use an x because that might confuse us. We might think that's another unknown number. Now, is this true? Does 11 times 4 equal 44? Absolutely. So 44 equals 44, and our equation is correct. We have equality on both sides of the equal sign. Okay, number 3, same idea, except the variable this time is on the other side of the equal sign. So I want to get the k by itself. I want to show what I do to both sides of the equal sign to isolate the k and get it by itself. Well, this is multiply by 9. The opposite of that is divide by 9. If I do it on that side, I have to do it on this side. Now let's see what's left. 36 divided by 9 is 4. And 9 divided by 9 is 1k. And that's the same as just saying 4 equals k. To check it, write the equation. And substitute your answer into the equation. So 36 equals 9. Replace the k, and this means multiply by whatever k is. Well, we said k is 4. Now, is this true? Does 36 equal 9 times 4? Absolutely. Both sides are the same? Check. Number 4, 32 equals 4g. We want to figure out what the variable g is. 32 equals 4 times a number. Well, to get the g by itself, we do the opposite of multiply by 4, which is divide by 4. And if we do that to that side of the equal sign, we have to do it there. Now let's see what's left on both sides. 32 divided by 4 is 8. 4 divided by 4 is 1g. And that's the same as saying 8 equals g. Exact same thing. Checking our answer, beside the equation, we'll write check. We'll write down the original equation, 32 equals 4g. We will substitute in 8 for g, so 4 multiplied by 8. Now, is that true? Is 32, little error there. So substitute in 8 for g. Is 32 equal to 4 times 8? Absolutely it is. So both sides are the same. We are good. Check. Now, we also did a few questions where we had to remember some of our mental division strategies. 6n equals 4,800. To get n by itself, we're going to divide by 6, and we have to do it to both sides of the equal sign. Now 6 divided by 6 is 1n. And on this one, we do 48 divided by 6 is 8, plus we have to tack on these 2 zeros for 800. And that's the same as just saying n equals 800. Checking it. 6n equals 4,800. Replace the n with 800. 6 multiplied by 800 equals 4,800. Is that true? Well, 6 times 8 is 48. Tack on 2 zeros. It absolutely is. Both sides of the equation are the same. We are good. Okay, very last question. Oh, giving it away. I forgot to erase this one. Okay, so we have 72,000 equals 80y. So we want to know the value of just y. So we want to make multiply by 80 go away. The way we do that is divide by 80. If I do it there, I've got to do it there. Now, we learned about a mental strategy this year where if you were dividing two numbers that end in 0, you can cancel off the common zeros. So we could cancel off these two zeros, and it's 7,200 divided by 8. We'll just do 72 divided by 8 is 9 equals, 72 divided by 8 is 9, but then we still have two zeros left to add on. So that'll be 900. And that equals 80 divided by 80 is 1y. Or just 900 equals y. And then finally the check. Write down the original equation, 72,000 equals 80y. Replace the y with your answer, which is 900. So 80 times 900. Now, is that true? Does 80 times 900 equal 72,000? Well, just do 8 times 9 is 72. There's 3 zeros to tack on. 72,000. Both sides of the equal sign are equal to 72,000. So I know my equation is correct. Check. So that's how you solve equations that have multiplication in them. You solve them by doing division. And you try to maintain that equality by doing the same thing to both sides of the equal sign. I hope that helps with the assignment today. That's all for now. Flexing Teacher Weber, out.